Hello everyone, and welcome to our video on simplifying trigonometric expressions. So if you haven't watched these videos in order, I would really strongly recommend watching these previous three because these are the foundation to simplify trigonometric expressions. Okay, and we have all these hints that can help with it along the way. However, I would think the main important thing is really let's just start this. Often it's best to write all trig functions in terms of sine and cosine. And then from there, I would say just try your best. Okay, so see what you can maybe think of as the next move and see if it works to simplify anything. If it doesn't, then we say, well, maybe there's a different move we could have done. Okay, so and if you want to, again, you could write all these down or if you have this already printed out, you could read through these and that might help, but I'm going to show you what I mean where I'm just saying, I think let's just try our best on these with just doing that first step and then continuing. Okay, so let's do that. So it says use the fundamental identities and appropriate algebraic operations to simplify each expression. When they say the fundamental identities, they mean the reciprocal identities, and they also mean the Pythagorean. Okay, so the reciprocal, as a reminder, let's put that right here, The reciprocal is using, it's the other four trig functions, just in forms of sines and cosines. So for instance, like tangent of, let's use theta, is sine of theta over cosine of theta. Cotangent of theta is cosine of theta over sine of theta. And then we have, what are the ones? Cosecant, there it is. Cosecant of theta is 1 over sine of theta, and secant of theta is 1 over cosine of theta. Okay, so those are our main ones. Okay, so and I don't have them written anywhere, do I? And okay, so yeah, let's keep copying. Okay, so the Pythagorean, so we need these. So that's really that first step. So that start thing, that's this. Just changing them into terms of sine and cosine. The next identities are the Pythagorean. All right, so the Pythagorean identities. Okay, so let's put that down. Well, we'll put it right here. I think that will be enough room still. The Pythagorean identities. Sine squared theta plus cosine squared theta is the main one, equal to 1. So sine squared theta plus cosine squared theta equals 1 is the main Pythagorean identity. Now, this gets manipulated a lot. So for instance, if this, like, sine squared theta can get subtracted over, and we would have 1, well, let's put cosine here. Cosine squared theta equals 1 minus sine squared theta. Okay, so that's taking the original and dividing sine, or not dividing, subtracting sine squared of theta over. Similar, if we subtracted cosine squared instead, we would have had sine squared of theta equals 1 minus cosine squared of theta, like that. Okay, so we can see different ways to get our trig functions isolated. Okay, so those are our main ones, and if we apply the reciprocal identities first, those should really be the only ones that we need. However, the other two, or the other different ones with non-sine and cosines, come from, again, the main one. If you divide all of these by cosine squared, here's our other, I'm going to even put it a little lower. Oops, that should be a 2. I was writing the theta too high. So tangent squared theta plus 1 equals secant squared theta. And then we could also move things around in this equation like we did with the sine squared and cosine squared identity. Okay, but back to the original where my arrow is, if we divided all of these by sine squared of theta, we get the last identity right there. So one of the last fundamental identities. Okay, so there's our Pythagorean. Again, we really shouldn't, I don't think we'll need anything besides these top ones, but there they are just in case, the others. All right, now that we've got our identities, now let's get down to business. So number 1, first step, let's change tangent of x into sine of x over cosine of x. This sine of x is fine, but let's use a placeholder in the denominator as 1. And then secant of x is 1 over cosine of x. Okay, so it looks something like this. So we applied the reciprocal identities. Now let's continue simplifying. So this is all multiplication. So the sine of x and sine of x in the numerator would multiply to be sine squared of x. Cosine of x times 1 would be cosine of x. And then in the denominator, we have 1 over cosine of x. All right, so here's where I still use my rule that we often use when we have like tangents. So for instance, we've seen a lot of things like this, where if you had like the square root of 5 over 6 divided by 2 over, well, let's not do 2, let's do 1 over 6. So we've seen stuff like this before. And my strategy on that was always to just multiply by whatever this denominator is. And then on this one, in this made up example down below, we get canceling, and we're left with the square root of 5 in the numerator and 1 in the denominator. Okay, so it's a quick way to clean up a complex fraction. So that's what we'll do on this one here. So we have our numerator and denominator both in the big parentheses, but I see, oh, how nice. The cosine of x is the same small denominator in each. So I'm going to multiply both the top and bottom by cosine of x. And if, again, we want to, we can put a placeholder. Okay, so this is a legal math move. Again, whenever you have a fraction, as long as you multiply the top and the bottom by the same thing, it's good. You can do that. All right, and then now that we've done that, well, what's going to happen is this cosine of x and that cosine of x cancel. And then this cosine of x and that cosine of x cancel. So we're left with, let's show this the long way. We're left with sine squared of x over 1 divided by, well, 1 over 1. And we don't really need to see all those 1's in denominators. So our final answer is sine squared of x. Oops, and I pushed something to freak it out. Okay, so that was our final answer there. Okay, that was just scratch work. Okay, so that's how these ones break down. All right, so let's try number 2. So again, same exact strategy always, just rewrite them all in terms of sines and cosines. So this cosecant of t, let's set up our big fraction, is the same thing as 1 over sine of t. And then minus sine of t, let's use a placeholder, sine of t over 1. And then this cotangent of t is cosine of t over sine of t. Okay, so there's all the replacements. And then this whole numerator's in parentheses, this whole denominator's in parentheses. However, they're being nice again. Notice that our denominator, the small denominators there that I put in blue parentheses, are the same. So what we'll do is multiply this whole numerator by sine of t and the whole denominator by sine of t. And if we want to, we could still throw a 1 down there. There we are. Now, this numerator does have a minus sign in it, so this sine of t does distribute. Down below, there's no addition or subtraction, so that means it just multiplies like normal. Okay, so let's break this down. So big fraction bar. In my numerator, when the sine of t multiplies this fraction, notice we would have 1 times sine of t, and then over sine of t times 1. Again, we don't really need to show those 1's. I just wanted to on this problem. And then minus, now the second part, when it multiplies this, sine of t would times sine of t, that is sine squared of t. And then 1 would times 1, and that's still 1. Down below, let's highlight, this sine of t and that sine of t would just cancel out immediately. And then we don't need to put a 1, so it is left down there with a 1 in the most down denominator. However, this cosine of t is still there, so it's just cosine of t. Again, we don't need to put over 1 anymore. We'll just leave it like that. Now let's look at what we had left over in the numerator. So notice here I have sine of t and sine of t. They would just cancel. Okay, so now we've got, that's all just 1. and then minus sine squared of t over 1. Again, we don't need to write over 1. Let's just write it as sine squared of t. And then our denominator is cosine of t. There we go. Okay, so we're getting there. That looks pretty good. However, it can simplify a little further. Okay, so the reason it can simplify a little further is because, look at this. That's one of the Pythagorean identities that we just wrote. Okay, so it's right here, that one. Okay, so I might erase that arrow in a second, but it is that one. So it's now the variable can change, so it's t instead of theta, but we do see, 1 minus sine squared of theta is cosine squared of theta. That means 1 minus sine squared of t is the same thing as cosine squared of t. And then now this problem, let's see, yep, let me scroll just a little bit. Now this leftover problem, again, it's the cosine squared and cosine are the same base. It is simplifying something that's just like this. Okay, so just my little side cloud scratch work where we can reduce it because this is x times x over x, so those x's would cancel. Let me keep my cloud going. Okay, so same deal over here. The cosine of t squared is cosine of t times cosine of t, still over cosine of t, and then cosine of t cancel. We're left with a single cosine of t. Okay, so that's how that fully simplifies. Okay, so that's how these ones break down. Let's try that number 3 here. Okay, so last one. So number 3, we've got secant cubed y minus secant of y over 3 secant of y tangent of y. All right, so still, I'm going to rewrite all of these in terms of sines and cosines. Okay, so the box is in the way a little bit. I think we can fit it. Okay, so secant cubed of y would be 1 over cosine cubed y. Okay, so the power stays with it. Okay, so we just rewrote that one. And then still minus. Secant of y is 1 over cosine of y. And then we have our big fraction. And then we have 3. Secant of y, still 1 over cosine of y. Tangent of y is sine of y over cosine of y. Okay, so we rewrote all of them. And then we can still put that 3 with a 1 under it if we want to. Okay, so we're getting there. Okay, so let's see how this continues to simplify. So let's move it down here. Okay, so I'm going to leave the numerator alone. So we have 1 over cosine cubed y minus 1 over cosine of y. The denominator, I'm going to do the 3 times 1 times sine of y would be 3 sine of y over cosine of y, and cosine of y is cosine squared y. Okay, so I've got my big numerator, I've got my big denominator. Okay, so these are kind of common here. So what happened in problem 1 and problem 2 is again happening here. In the blue, we do have a bunch of cosines in these small denominators. What we want to do is take whatever the highest powered one is, so on this problem it's cube, and multiply both the top and bottom by that highest powered cosine. So cosine cubed and cosine cubed. This time I'm going to avoid writing the 1, and then let's see how this goes. So the cosine cubed will multiply up top by distributing, and then the bottom doesn't have any addition or subtraction, so that's going to multiply just with regular multiplication. Okay, so in the top, let's see how this goes. Okay, so cosine cubed y times the 1 is cosine cubed y, still over cosine cubed y, minus the 1 times cosine cubed is cosine cubed y over cosine of y. And then in the denominator, we would have just some reducing. Let's do that right now. This cosine squared of y would reduce with cosine cubed y. So we would lose one, or we'd lose the 2 powers on it. So this whole cosine squared cancels with a little bit of that. So that would now become the first power of cosine. So now we're left with, in the denominator, 3 sine of y cosine of y. Okay, now let's simplify our numerator parts. Let's get our big fraction. So the first one, cosine cubed over cosine cubed is 1. And then minus cosine cubed over cosine of y, that would be cosine squared of y. And then still over 3 sine of y, cosine of y. And then we see it again. Oh, look at that. 1 minus cosine squared of y. This here is a Pythagorean identity. Now it's this bottom one, this one here. 1 minus cosine squared of theta is sine squared of theta. So that means this numerator becomes sine squared of y, just keep the whatever the letter is, over 3 sine of y cosine of y. Now that it's all multiplication in this fraction, we can do one last thing as simplifying. This sine squared of y and that sine of y reduce. So we would be left with, in the numerator, sine of y. In the denominator, 3 cosine of y. Okay, so a little low on space, that's a y. And then lastly, so this might be fine as a final answer. I'm going to box it. But they might say, oh, you have sine over cosine. That's tangent. So let's highlight that. Sine over cosine is tangent of y. Now the 3 is in the denominator. So careful of that. There is a 1 with the sine of y. So this would be 1/3 and then tangent of y. Okay. Or, okay, so real low on room. Or tangent of y over 3. Okay, so those are 3 different ways to write the same thing for a final answer. Okay, so that's our what am I thinking? Identities. Okay, so simplifying. So that losing my brain after a pretty long one. Okay, so they can be tricky. Okay, so but try to keep your work as organized as possible. Also remember you can only cancel when there's multiplication going on. So for instance, like back to number 3. So I'm going to erase this. You can't say, oh, this secant of y and that secant of y cancel. No, that's not how it works because it wants to subtract in the numerator first and then carry out the rest of the process. So if it was regular numbers, we know, let me do one very quick side example. So if it was regular numbers like 5 minus 3 over 3 times 2 times 7, again, we know we can't take this 3 and that 3 and cancel. That would be illegal. What should have happened is 5 minus 3 should be 2. And then now I can do some canceling because now I have a product. This 2 and that 2 cancel. So it should have been 1 over 21. Okay, whereas if we illegally canceled that 3 and that 3 out, then I don't think we're getting 1 over 21. Okay, so I mean the math is all bad at that point anyway. Okay, so if you're ever confused with any of the rules, just make one up like I did here with numbers. Just make stuff up with numbers, and whatever the rules are for the numbers, it's going to be the same for the variables. Okay, so tough problems. All right, let's take a break. Thanks for watching, and I hope to see you again.